Welcome to this month's webinar. I'm joined today by Brian McEwen. Brian is our Director of Client Enrichment and has worked at Sawtooth Software for 13 years. If you've ever had a demonstration of our software or attended one of our workshops over the years, you've probably had a chance to interact with Brian. Our webinar today is on improving and optimizing your offerings with conjoint analysis market simulations. And with that, take it away, Brian.
Thanks. All right, I'm excited to talk about improving and optimizing in our simulators today. Now, at Sawtooth, we love our market simulators. Depending on where you're at in your experience with Conjoint, you might be brand new, you might have a couple studies under your belt, but we know that although we're doing a lot of powerful math and coming up with models that are fitting choices and doing some complicated things, at the end, when we get into our simulator, it kind of feels like we're bringing us back down to reality a little bit. We're taking these things we call utilities and turning them into share predictions, choice predictions that are a lot more digestible regardless of your background. So we love our simulators. They help orient us into reality about what all these numbers mean, to give us our demand predictions and our revenue estimates and things like that. They add context also to our attribute importance scores that can be sometimes a bit misleading if you just look at them in a vacuum. And simulators are the gateway to further cool things like estimating price elasticity, or a willingness to pay, or things like that. So this particular webinar is not going to be on simulator basics. We've done that a couple times. There are some links to those, and these slides, we'll just clarify, will be available for download once this gets posted. So you'll have these links, and they're on our website. All our webinars are free. We also have some on more advanced topics like calculating willingness to pay and things like that. So today we're just focused on kind of a little bit of a narrow part of the whole simulator ecosystem is how to find improvements to product offerings, service offerings, et cetera, through two different particular things that we can do. First being just some more simple recommendations, and then we'll talk about actual optimizations. So recommendations, kind of tongue-in-cheek here. We could call this a little bit of AI if we were trying to get people excited. But recommendations are essentially just doing a little bit of sorting after we run a series of simulations. We call this sensitivity analysis. So we're going to kind of hold things constant. We're going to run a particular product through all levels of an attribute. And then we're just going to sort that essentially best to worst, apply that AI to it in order to give you the best to the worst changes that you can make. So recommendations are kind of a simplified approach to improvements that are available in our online platform Discover, and then its standalone complement, which is available at app.sawtoothsoftware.com. So a standard market simulation, we run our conjoint, we build our model, it tells us all the utilities and things. A standard simulation lets us create particular configurations. So in this case, we have 3 different credit card offerings, and we would use the utility model to predict the result of that particular outcome. So in this case, we'd predict that a bit more than half of the people would choose the first product offering here. And that's it, just kind of a one-off. Here's the scenario, here's the results. What a sensitivity does is we're going to identify an attribute of interest, hold everything else constant, and then just kind of systematically step through all of those levels and kind of more visualize the connection between how share changes versus how the configuration changes. So for example, we might say, let's do a sensitivity analysis on the credit limit attribute of product 1. And so what this would do is products 2 and 3 would hold everything constant. and then we would run the simulation 3 different times. We'd start it off at level 1, then move it up to level 2, then move it up to level 3. So we're not really fundamentally changing anything we're doing here. We would get the exact same share numbers if we just did this 3 times ourselves. So sensitivity is really just kind of like an automation step. And that would then give us kind of this separate view rather than just 3 share outputs. We'd kind of connect them a little bit, and we'd say, here's how share goes up as the credit limit goes up. So again, nothing too fancy, just kind of a little bit of an automation step to save us from handfuls of clicking in order to see how, if we hold everything constant, how our share predictions go up or down as we change the levels of a particular attribute. Okay, so if we then sort things, then we would be able to say our first recommendation would be holding everything else constant, change your credit limit from 2,500 up to 7,500, and that would result in a 14% increase in share. And then our second recommendation would be you could change the credit limit from 2,500 to 5,000, and that would give you a 4% increase in share. Okay, now we've made this really easy to do, basically just kind of a click of a button. So I'm going to switch over here. So I have a different survey here. This is a survey we ran about some electric vehicle preferences. And we've got a couple different products configured here, plus a none choice. So again, our standard simulation would just say, given these options, we get our particular share results for each of these. Now we have a second scenario set up, and if we want to look at those recommendations, we come down here to the simulation insights area. We can say, let's do a recommendation. And then there's a gear icon here where we can choose 1 or more products to run. So I've currently got it selected to do this recommendation on the Kia option, our third option. So what it's going to do is it's going to hold the first 2 products constant, and then it's just going to start cycling through. Attribute 1, change all the levels. Attribute 2, change all the levels. Attribute 3, change all the levels, and just step through each of those kind of one-way changes for things. And then it's going to sort them and say, the best that you can do is you could change your brand to Tesla. And we could look at that and we can say, well, that's kind of a silly recommendation in this case. The software doesn't know that brand is probably not something we have a lot of control over. So we can come in and, again, in this gear icon here, we can drop this down and we can say, don't show me any recommendations for brand. That one's going to be fixed. It has to be a Kia, but go ahead and do it for everything else. And so again, this would step through, only this time it's going to skip the brand attribute, and then it's going to step through the type of car, the range, some warranties, and our price attribute, and then give us, again, sorted best to worst, the recommendations. So given the competitive set of products here, we could get about just shy of a 6% boost if we changed it from a sedan to an SUV, or if we changed it from the 2-door option to the 4-door option, or if we dropped the price, etc. So that is our product recommendations kind of engine in Discover. If you want to kind of peel back the curtains a little bit, and instead of doing this sorting best to worst, then you can run the full sensitivity and see the results of everything. So if you come back down to the simulation insights area, and instead of recommendations, you run a full sensitivity, again, you can choose the particular product, you can turn on and off the attributes here, and it's going to run the same thing. Step through every attribute one at a time and make all the one-way changes. But instead of sorting them for you, it's going to give you kind of that more traditional sensitivity curve view. So the blue dots here represent the level that it's currently set at. We sometimes call that the base case in Conjoint lingo. So we can see, for example, this is the share at the current configuration of $4,500. And we can get, for example, a price sensitivity curve here on the product. So that's really the only difference. Recommendations will just sort them best to worst. The full sensitivity will just show you all possible options here. Okay, so hopefully that makes sense. We've made it nice and easy just to push some buttons and get some nudges in the right direction for you. Okay, so recommendations, like we said, are a look at every possible kind of one-way step away from the current configuration. And while this will definitely find some good recommendations, it's not necessarily going to find the overall optimal configuration. To do that, we would need to be able to change different attributes at the same time so that we're kind of considering, the whole design space, all possible configurations of options, instead of just every one-way step away from the current configuration. So that's really the difference between running a sensitivity where you step through things versus a full optimization where we're kind of considering all possible combinations of things. So if we wanted to get towards optimization, and then in theory, we could just do exhaustive sensitivities, right? We could, holding everything else constant, we could run the product at level 111, and then 112, 113, and then 1121, and just over and over again, we could eventually test all possible combinations. And so that is a viable option that we can do. So that is one of the algorithms that we're going to talk about in our desktop software. So if you're a Lighthouse Studio user or its standalone component, we have a standalone desktop simulator. These are algorithms for doing full-blown optimization to try to find the particular configuration that's going to do the best. So the first one is just our brute force exhaustive. Let's look at all possible combinations of things. Now that's great. That's guaranteed that we're going to find the best configuration and the second best configuration and the third best configuration. The problem with brute force methods is that they kind of break down when the search space gets really, really big. So as an example, say we had kind of a larger size conjoint, 10 attributes, each with 5 levels. Then we have 5 to the 10th possible product configurations, which works out to be about 10 million. And so it's, it's doable, but it's probably going to take a decent amount of time. And then as you start expanding the scope of your searches, for example, maybe we had 2 products we want to optimize together against some competitor offerings, then we're just going to multiply that together, 10 million times 10 million, and so on. So for larger optimization problems, this brute force exhaustive one might take hours, might take days, might even take weeks to evaluate all those possible combinations. So exhaustive eventually hits a limit where it's just too big, too much to try to just brute force our way through the problem. So we offer a couple different algorithms in addition to this. The second one that we do is called a grid algorithm, sometimes called a hill climbing algorithm. So the idea behind this is that we're definitely not going to test all possible combinations. We're going to choose a starting point. So this graph is kind of like a 3D representation of where we start at the beginning. We would create maybe like a random configuration of a product. We can also do it intelligently by like starting off with the best level of each attribute, the one that has the highest utility. And then we would start with that configuration, and then we would start at attribute 1, and we would say, are there any changes we can make that climb up the hill, that improve the share of the offering? And we would do that, and then we would lock that attribute in, and then we would move to attribute 2 and say, okay, are there any directions I can go to further climb up the hill and make the product better, increase its share, increase its revenue, or something like that? So you go through things, and then eventually you get to the top of a hill, and there's nowhere left to go but down. And so the algorithm stops and says, here is a solution that I found. So generally speaking, you can do a pretty good job with grid algorithms as long as you do them several different times. So by default, we will run this 10 times using 10 different starting points to try to avoid always climbing up a small hill when there might be a bigger hill somewhere off the map a bit further. So it's a it's a definite compromise solution. We're definitely not guaranteed to find the optimal solution, but we still have a pretty good chance as long as we use a bunch of different starting points and repeat things several different times. Okay, so that's our second algorithm, grid. It is much faster than exhaustive, and generally a pretty good option. All right, so the third one is an attempt to kind of try to find a middle ground between these two approaches. So exhaustive, all possible combinations, definitely will find the best solution. Grid, much faster, but not guaranteed. So is there some way that we can do a better job? For example, we know that some levels are just not really good. Nobody liked them in the exercise. And maybe we can introduce an element of randomness so that we can try to not always just objectively march up the closest hill next to us. Maybe sometimes we can take a big jump and land on a different part of the map and then start climbing up the hill. So to do that, we're going to introduce some evolutionary ideas here, along with the idea of survival of the fittest, kind of a predator-prey relationship. So I'm gonna kind of geek out a little bit. I think this is probably one of the coolest conceptual algorithms that I deal with. So it's a lot of fun to talk about. So what we're going to do is we're going to treat this kind of like a National Geographic documentary or something like that. And we're going to call this a genetic algorithm that is going to create organisms, members of the herd, and then they're going to go through some life cycles here. So the first step in our genetic algorithm is that we're going to create the herd. So by default, we're going to generate 300 different configurations. If there is that many, we're going to generate 300 configurations. We might generate those randomly, or we might use like our grid search to try to find a bunch of good solutions. So in our electric vehicle survey, this is going to be like a Tesla configuration, and then a Kia, and then a Toyota. So we're going to make a big herd of all sorts of different animals, different configurations of our electric vehicles. Next, we're going to release the predators. So the predators are going to trim the herd by about half. So the top 300 fittest members, the ones that produce the highest share or the highest revenue, that's how we're going to say they're kind of the healthiest. They're the alphas of the herd. They're going to survive, and the other ones are going to get eaten by the predators, and they return to the circle of life. Then once we have those 150 survivors, they are going to pair together and create the next generation of 300 offspring. So there's an element here that if you're very fit, you're at the top end of the herd, then it's likely that you're going to be paired together with another top end. It's not guaranteed, it's kind of a probabilistic thing, but kind of mirrors the domination of good traits, right? So we have an example here where parent A has its configuration and parent B has its configuration, and then the offspring is going to usually have the best characteristic of the parent, but there's an opportunity for mutations to occur. So in this case, in the price, the offspring got some recessive gene from some ancestor. It got some mutation that it was not exactly the same thing as the first parent or the second parent. So this introduces the bit of randomness so that we don't, hopefully don't get stuck on some local small hills as we go through this. So we keep doing that over and over and over again until the generations produce no significant gains. We also typically have a hard cap on the number of iterations that will run, and eventually we end up with a lot of really good solutions over generations and generations of the best mating and having offsprings and things like that. So it's a really fun algorithm. It's a really interesting one to think about, and I just think it's so interesting to have taken that and applied it to something like conjoint analysis market simulators to optimize products. So that's our third option, called genetic. Generally, you're going to hit some point where the genetic algorithm is going to be faster than the exhaustive, and that speed is going to kind of increase the greater the search space becomes. And oftentimes it can do a really good job, even in those really large search spaces, to find really, really good solutions. Again, it's not guaranteed that it's going to find the global optimal solution, but the way that it works, it's just less vulnerable to finding, getting stuck on small hills when a bigger hill exists a little bit further off. If you want to read some additional details about this, we have a technical paper. It's linked in the bottom left of this slide where you can kind of read a bit more of the details. There's certain things in the algorithm that the user can tweak and play around with and things like that. So that's a helpful resource if you want to dig a little bit more into that. Okay, so I'm going to show you how some of these algorithms work. So again, we're going to be in the our desktop simulator here. So our desktop simulator conceptually works a lot similar to the online ones. You have a product grid. You define what the product configurations are. You hit simulate, and again, this is a standard simulation here. So we're just saying, here's the three options, and we get our share predictions of how respondents would choose. So that part's basically identical to between the online and the desktop software. We don't have the shortcut recommendations options. There's just running sensitivities, and we do that in the desktop simulator by putting in ranges of values here. So you can either do kind of a shorthand. We could do 35,000 dash 65,000, and that would just automatically run it at each level. Or you can get a little fancy, and in this third cell, we have this range function here. This allows us to do a specific step size. So we can say, instead of just jumping 10,000 increments like the levels were, we can say, let's go ahead and run every $2,000 increment to look at that. So that will produce a curve for the product here. And then if we want to do our optimizations, the same approach exists. We can put in ranges. So this is going to define the search space. But instead of doing a sensitivity, there's the setting here for range behavior. We can choose one of those three search algorithms here. So this is kind of our contextual menu here. There's kind of some global settings. And then as I switch tabs, you can see the name of the contextual menu up here changes to give us some extra options for this particular tab here. So we can drop this down. We can say, let's run a search. And in this case, we're doing an exhaustive, and the search space is very small here. It runs very fast, and then gives us our results, but again, sorted. So we're changing the price. We're testing 35, 37, 39, et cetera, each $2,000 increment. And then the software will sort these best to worst on the outcomes for the product. So again, not too much effort. That's the general idea for any of these searches, is define the search space by implementing ranges here. And then we do also have the option to change what the goals are. So by default, it's going to do a share optimization. It's going to try it's going to sort these best to worst based on the overall share. In this tab, we have kicked things up a notch. I'm not actually going to run this. It takes a couple minutes, and that would be kind of boring for us to sit here while it ran. But I've defined the search space by saying it has to be Kia, so that's set, but it can be any level of the type of vehicle, the range, the warranties, and then anything between our min and max price in $2,000 increments. But this time I've gone in here and I've done a couple different things. The first thing is back in the project, setting it up as a whole. I've come into this revenue and costs area. And I've added some extra numbers here so we can do a bit more math. So the first one I've done is I've said, let's assume there is a market out there with 50,000 purchasers in it. So instead of just giving me a share, I can now multiply the share by the market size and get some volume estimates. I've also told the software that the last attribute is a price attribute, and I've given it numeric values. So if I sell the car at $35,000, then it should be thinking about 35,000 units. So for me, dollars is how I have it set up, but we're giving it a numerical value. So again, we can cross multiply and say, all right, 50,000 units, we're selling them for $35,000. So if we sell X number of units, now I can do a revenue projection, kind of just doing the math for you to come up with that. And we've set up a cost table here. So I'm kind of thinking in terms of like manufacturing costs. It costs me $10,000 to make the two-door sedan. It costs me $14,000 to make the four-door sedan. So these are additional metrics that we can add into this desktop simulator so that we can go beyond share and think about doing multi-objective optimizations. Instead of just saying, give me the best share or give me the best revenue, once I set up these additional metrics, then I can go to my search settings and I can choose more than one objective. So in this particular case, I've said I don't want to just maximize the share, but I also want to maximize the profit. So look through all those solutions and find me and kind of sort them based on doing well on both metrics, not just one. So again, define the search space, define the goals, push simulate, let it sit for a few minutes here, and then our results are going to sort these items based on both the share and the profit that they produce. We also calculate what's commonly known as a domination rank. So all of these options here are all kind of tied for first place. They trade off small amounts of share and profit, but they're all kind of the tier one. They're on the outer edge of this curve that has been built here. And then as we continue to scroll down, eventually we hit kind of a tier two solution where the tier two solutions are kind of objectively worse on both metrics than all of the tier one solutions. And then visually, we have a little graph here that kind of shows us the curve in this relationship as how profit changes and share changes together. So that's a lot of fun. Again, we can do this either as a exhaustive, or we could use the genetic algorithm. It just kind of depends on how big your search space. Eventually, you'll say, I don't want to wait an hour for this to run. Maybe it's time to drop the exhaustive and switch to the genetic algorithm. And there's some other fun things you can do. Again, we have a separate webinar that goes into a lot of detail for a lot of our settings here. In this situation, I've kind of trimmed the search. So in my settings, I came to our filters area and I said, I really don't want to see anything that doesn't produce a share of at least 25% here. So this allows you to kind of further refine the search space, but instead of doing it from an attribute and level configuration, you kind of trim it from the outcomes. So we can say, I need to see something with at least this amount of share, or at least this amount of revenue, profit, volume, or some of these you can do per unit, like I need at least dollar per unit profit on the options or something like that. Okay. Now, the neat part about the desktop simulator is that this is shareable for free with other people. So if you have a license to run simulations and do these optimization searches, and then you decide you want to create what we usually call a client simulator package, this will take this either in Lighthouse or the standalone version. It will take this, export it out to a standalone file. The other user does need to install the software, but they can do all of this stuff on their own, and they don't need to be a licensed user. They can't go back and like change the model. They can't change the data or anything like this, but they can take this and run with it and do all this searching and sensitivity runs and simulations on their own, which is a pretty fun thing to be able to deliver to someone else. Okay, with that, I think we've pretty much covered everything we wanted to with our recommendations and our optimizations. I think we'll go ahead and open it up for some Q&A if we've had anything coming into the chat, Christina.
Yes. So we had a couple of questions, but just so everyone knows, if you do have questions later, my name is Christina Hubner, and I'm the manager of our client services team. So you can feel free to reach out to our support team at support@sawtoothsoftware.com. So don't feel like this is the only moment you can ask questions, but we did have a couple. The first was wondering, can we enter cost for combination of different attribute levels? For example, a 4-door sedan with warranty level 1 costs XXX, while a 4-door sedan with warranty level 2 costs YYY.
Mm-hmm. Yeah, so we, in true Sawtooth approach to things, we do let you get complicated on things. So when you come into the costs area and you add, you click the add button, you can do it for one attribute at a time, which is what I have done here. I said, this is going to be based on the style of the option. You can get complicated and make conditional costs. So we could say the brand and the range have different costs, maybe. So, Tesla can provide these different ranges at a lower cost than some of the other competitor brands or something like that. So you can get complicated and do this kind of conditional cost table here. Yep, good question.
Great. The next question is, can the optimization be set so that you can find the best revenue, for example, of a set of products, assuming a manufacturer may have several products in the market?
So I think that's basically saying, can we optimize on more than one product at a time? Is that what you're thinking that question is?
I think so as well. I feel that they're probably saying, assuming that your client is one manufacturer, but they have multiple products probably out in the market.
Yeah. So Kia is not just going to have this one car. They're probably going to have, maybe they're going to have a 2-door sedan with a low range and a 2-door sedan with a high range. What can we do to kind of make both of those things as good as possible?
Yes.
So yeah, it's totally possible to do that. If I were to make a second Kia option here, and if I put similar ranges into it to define the search space, then that is going to make it a searchable option now that goes into the overall objective function. So we would be trying to make the share and the profit of both of these options. So if I just did, something like that, in reality, we'd probably say, like, let's do a 2-door and a 4-door, for example. So we lock that one, but these are both searchable options. Then the combined share and profit of both of these is the objective that's being maximized now, being optimized. So yeah, that's definitely doable. You can include the share across multiple products. You can also include the share of a static product. So say we had, I'm just going to copy and paste this for simplicity's sake. Say we had a Kia that was flexible, but we didn't have a particular configuration on, but the second Kia, there's no changes, like that's the one. So we want to maximize Kia overall, but we're only changing this third product here. So you can do that by coming in, and so in our settings of our search, there's a setting here that says products included in the objective. So since there's no searching going on, there's no defined space for this second product, I come in here to this setting and I say, include the share and the profit produced by product 4 when evaluating all the different combinations of product 3. So both of those situations you can do. You can search on multiple products, or you can search on one product, but include the combined share and revenue of more than one other product.
Great. One question that has come up a bit that I think would be good to clarify is the recommendation option that's in Discover. Some are wondering if it's available elsewhere besides Discover.
Yeah, so the recommendation engine of holding everything constant and then stepping through everything one at a time, those recommendations are based off of running a sensitivity. So it's that little extra AI step where we just sort them best to worst. So it's really, you should just think of it as a different way of reporting the results to you. So behind the scenes, when we say run the recommendations on this Kia option, what it did is it said, hold everything constant and then run Kia as a 2-door sedan, a 4-door sedan, an SUV, and a pickup truck, and then move it back to 2-door sedan, which is its current configuration, and then run it at 350 range, 450 range, 550 range. And then from all of those small changes, just sort them best to worst. So of all those changes, the best you can do is to change from a 2-door sedan to an SUV, and that'll get you about a 6% boost. That step of sorting, we don't do that in the desktop simulator. When you run a sensitivity approach, either visually or looking through the results down here, it's going to default to the output of like the slide had 11111, 11112, 11113. So you can see it starts as is and says, here's it at level 1, here's it at the next increment, here's it at the next increment. So the sensitivity part does not do that last sorting for you. It is, we probably could just save this. We click this save button, we could save this out to Excel, and we can say like, find the ones that say Kia and then sort based on this cell. And that would be a way to kind of replicate it, to kind of get you most of the way there. But if you're in the desktop one, you would be better off just running an optimization, and that is going to expand the space. So instead of just looking at every one-way option, you are going to consider either all possible or do something like a genetic to really consider the broader whole design space rather than just the one-way steps. So you'd be better off doing an optimization in the desktop simulator. So hopefully that makes sense. So sensitivity in the desktop simulator doesn't do the last recommendation step and sort them for you. It kind of keeps it more 1111, 1112, 1113. So hopefully that makes sense.
Another option available to them is to export their utilities from Lighthouse Studio and put it into the online simulator in the Sawtooth Projects app.
That's true, yeah. So that the app.sawtoothsoftware.com, that is an option for taking a utility model from Lighthouse, and you can upload it, and then use the recommendations engine, potentially share it with other people if you don't want them to use the desktop simulator. You have to install and things like that. So all of these things, if you're on like our suite subscription that kind of gives you everything, you can do all of these things. But if you're just on like a standalone CBC license or something like that, then you wouldn't necessarily have access to everything that we've been talking about.
Thank you, Brian. I hope everyone has a wonderful day. And if you do have additional questions, again, feel free to reach out to us. We'll make these slides available, and we'll also let you know when this video is available. Thank you, everyone. Have a wonderful day.